Hello and welcome back to UAS3 training. In this chapter we will talk more in details about specific settings for LUBExpert. So let's go back to our tree structure that we created before, and now we will start adding some greasing points. So depending if you are working with both 270 and LUBExpert separately, if you are working with 270 with LUBExpert features, or you're working just with a LUBExpert, you have a possibility to separate this in a specific tree structure, which will be designated for the lube team, or you can have it all in one tree structure, which is very useful, because then you will have at one spot you will be able to see the condition of the asset from the condition monitoring perspective as well as from lubrication perspective. So let's build something within, let's say, pump, non-drive end bearing and drive end bearing. We will set up the lubrication points. The first step you need to do when you are preparing settings for your lubrication practice is to enter all your lubricants and grease gun into the database. So you will use options, system settings, and here in tab lubricants, lubricant management, you will add lubricant. Since we are not promoting anyone, let's call this lubricant blue, and also let's call another one red. So what you need to do is enter the name of the lubricant, press add, and then you will do save and close. Of course, the software is reminding you that you have to synchronize data with all your devices. Now we are not finished. We also need to add grease gun. This will be the last tab, grease gun management. You don't need to exit this menu. You could have just go to next tab and add grease guns and then save and close. But I'm just showing you another way. So again, grease gun, what you need to do is a grease gun ID. So there could be a name of the grease gun, or you might be using a color code. So let's use blue. And it is mandatory to enter amount of grease per stroke. So what is the output of the grease gun? So let's say this one has 1.25 grams per stroke, and press add. Another one, let's call it red, so it will correspond with our color code that we use on the asset marked with red. We are using the grease marked with red and named red, and also we are applying it with a grease gun which is marked as red. So let's put on this one 1.5 grams per grease, and we will edit and just click save and close. Of course, again, you will synchronize it with your instrument a little bit later. So now we have lubricants and grease gun in our database. Now let's go to the bearing itself. Pump, non-drive end bearing. Let's add new measurement settings. Choose the sensor LubeSense 1. And now, depending if you are working with LUBExpert Dynamic, if you are working with 270 version DU with LUBExpert features, or you are working with LUBExpert Static, you will choose here what kind of data you want, dynamic or static. So at this point I'm working with dynamic data, so I will use dynamic data, but if you are working with static only, it doesn't make any difference. Your process will be completely the same. So the next field you have to enter is interval. In our trainings you can learn more about how to set the interval. In this session, the target is just to show you how to do it in the software. So I will choose 1 month, and for this bearing, for the pump non-drive end, I will choose blue grease, and I will apply it with a blue grease gun. So as you can see, there is a small information on the side. You don't need to go back into the settings. You can see what is the output of this grease gun. Now, next thing you have to enter is type of the bearing. Of course, you can click here and then scroll down and find your bearing. But there is another way. So let me go back just to remind it. So click on the pencil and the menu will open with your bearing database. Here you can add a new bearing into your database, you can edit existing bearings, you can delete them, and you have a search field where you can search bearings. So let's say that this bearing that I want to enter now is 6318. So it's immediately narrowed down to 3 options. So by double clicking this option, it will be added to my settings. So bearing outer diameter, inner diameter and width is added, and I can move on to following fields. Next one is rotating speed. So I will enter my rotating speed, 2985, let's say, RPM. What is the type of replenishment, side or annular? Let's say that in this case is side. And I need also to define acquisition time. So if I click on the drop-down menu, there is a minimum acquisition time for this bearing in particular, and this speed 2 seconds, and the recommended one is 5 seconds. So I will choose recommended one because these 3 seconds of longer acquisition time will not really change much, but the data will be more consistent. And more or less I am now done with my settings. So we can just check it out again. Interval is 1 month. I need to use blue grease with the blue grease gun. The bearing I'm greasing is 6318. Rotating speed 2985. It's a side replenishment. Acquisition time will be 5 seconds. Maximum acceptable grease gun output is 13.2 grams per shot. So this field is warning you in case you are using a grease gun with too big output for that particular bearing. And my stabilization time, so the time after applying grease and before taking the measurement, will be 7 seconds. It's automatically calculated. So since we are here, let's just see another options that you might choose. Acquisition time can be minimum 2 seconds, recommended 5 seconds, or any other acquisition time. So I can put 75 here, and that's absolutely fine. I cannot put 81 because maximum acquisition time of LUBExpert is 80 seconds, and I cannot put 1 second. Simply because acquisition time is lower than minimum defined for this particular bearing. So I can use 2, I can use 7, 19, 25. It's your decision. Of course, the best way is to use recommended time because it's pre-calculated, and that would be the best choice. The second thing is that you can change adjusted calculated grease quantity. So this part here is based on all other inserted data, calculated what is the theoretical quantity. That quantity is not the quantity that you will inject in your bearing. This quantity serves the purpose to calculate the optimum steps. So that means you will be adding grease in steps, slowly in projected quantities, but that projected quantities come from this data. So in this case, the recommendation is to start with 8 shots, and then 4 shots, and then 3 shots. So we will gradually decreasing the injected quantity in each step. Of course, based on data, you can choose this. So that decision should be done based on data, and you can learn about it in our training. Here I just want to show you how to do it. So you can click on edit here. You will be warned that you should not be changing this quantity more than 30% increase or decrease. It's a safety feature, because if you just put any quantity, some enormous quantity, that means that first step will be too big, and you might overgrease your bearing immediately. So it's a good idea to follow the recommendations here and not to change it more than 30%. So I can change it, and I can say that based on my data, based on my interval and how often I visit this bearing, that my usual quantity is rolling somewhere around 30 grams, and I can save it. So you can see now that it's edited. It's something that I inserted. I overridden the calculations, and it's displayed differently. If I want to go back to originally calculated quantity, I will just press here. So that means that the replenishment quantity will be the quantity decided in the field by LUBExpert algorithm, but this is defining my steps. You can also change another thing, and that's the replenishment. So is it side or annular replenishment? Depends on configuration of the bearing. So you can see in this configuration with a side replenishment, the quantity 40 grams is defining steps by 8, 4, 3, and then following steps. But if I change it to annular, the calculated quantity is 16. So that means that your recommended steps, which will be you will be instructed about in your LUBExpert, are 3, 1, 1, and then following by each following step 1. So once I'm done with these settings, in order to save some time, I can also copy settings here for some other bearing, or the same bearing for the static configuration, and I will press save. So as you can see here, my bearing now, my settings for the lubrication of this bearing is added to my measurement point. So let's just say that I have the same bearing on the drive end. Measurement settings. I will click Lube Sense. Again, dynamic, because I'm using dynamic. What I can do here is simply paste settings. So if we are talking about the same bearing, same asset, same rotating speed, I'm using the same interval, same grease and same grease gun, I can just paste settings and everything is automatically inserted. Let me show you another option that you might need sometimes, because quite often we face the situation where the team is not aware what kind of bearing is actually installed in the asset. We need that bearing because of the size. Because of the size, to calculate the recommended steps, so not to push too much grease immediately or not to push too little grease immediately, to have some optimized workflow. But very often it happens that you simply don't know what kind of bearing is inside. So there is an option for that. You can add new bearing. First of all, if the bearing is not in our database, you can just add new bearing and have it in your database, so you will be developing your database with time. But also in a situation when you really don't know what kind of bearing is inside, but you know the approximate size, you can name it unknown as an example, and you can say that outer diameter is approximately somewhere around 180 millimeters. Inner diameter, let's say that it's somewhere around 60, and the bearing width is somewhere around 35. And you can write here that this is a temporary designation. Put it in, and here it is. Your bearing is now here. So now you can add this bearing to your settings. For the moment is unknown. Of course, the next one, if it's different, will be unknown 1 or temporary 2 or whatever. And then you will simply continue work until the first possible opportunity where you will know the exact designation of the bearing, and then you should insert it in so you can have your clean database with all accurate data inside. And then just press save, and it's added to your measurement point. So now we have our RS2T that we are using for condition monitoring. We are using our vibration, and in the same point we are also greasing this bearing, so we can all do it in one tree structure. Now let's add these 2 points to a work task. So call it new work order, and we can call it grease task or any other name you want. We created 2 points, so I will add another point here as well into the same grease task. So if I open my work order surveys, I have the one we did in the previous chapters, and now I also have the grease task, which is containing these 2 points that need to be greased. So from here, basically, we can take our instrument, go to field, collect data, and come back. So let's do it. As you know from previous chapters, we will now click on Device, LUBExpert, upload from PC to SDT270 or LUBExpert. It will detect device, and we will transfer all of the data. Of course, your instrument needs to be turned on and connected to your PC. So once data is transferred, everything we need is in our instrument now. So let's go to the field. And here we are. Our instrument, our simulator Rhapsody box, which will help us simulate the grease replenishment procedure. And also here is our Rhapsody box software, where we can control what happens with a Rhapsody box, and you can also here see how does it look like, what the signal will be, and what will LUBExpert face, let's say, in the field, in the Rhapsody box actually. So let's turn on the first scenario, so that will be lubrication success 1, and let's see what we have in a LUBExpert now. So what you will see on the screen first is your work orders. Press enter. Now you see all the work orders. The first one is grease task that we care about right now for the lubrication. We press enter, and we are in pump 2, non-dry vent bearing, and press enter again. Now you are reminded what kind of grease and what kind of grease gun you should use. Alarm is not assigned at this point. We will assign one later, and then we can play again, and we will just press enter to continue. As you can see, this is my measurement value. As you can see at the top of the screen, there is an arrow reminding me to change the amplification. If I just ignore it and press enter to take the measurement, the action is denied, because taking measurement with the wrong amplification is blocked in LUBExpert. So I will decrease my amplification until the arrow is gone, and okay, I can take my measurement now. So I'm taking my first measurement, and I will save it. And since we haven't had any alarm defined on this point, I have all options here. I can exit and just say I will not grease. I have a guided mode or free mode, or press M for message. So I will just press M, and I will say that lubrication is needed, and then I will choose F2 guided mode in this case. As you can see on the screen, alarm is not available. Since this moment I injected 0 grease, and it's telling me to add 8 shots of grease. I will just press here once, and that means that I added grease, and I will press enter. Now there's a stabilization time that was defined, 7 seconds, and now the measurement is being recorded. Okay, it's lubrication success. Add another 4 shots, so I will do exactly that, and continue the process. So this is actually, you will see this in the LUBExpert training, this is entire process of lubrication. Lubrication success, and instruction is to continue. Add another 3 shots, which I just did. Okay. And from this moment on, we will follow the instructions on the screen. LUBExpert will lead us to optimum friction level. Okay, lubrication success again. So we are continuing the process until we get a notification that task is completed, and we will see what will be the outcome. Okay, still continue. Okay, now we are done. Task is completed with outcome as lubrication success. With start and finish value, we will acknowledge this message, and we'll continue to follow the next bearing, which is pump number 2, pump drive end bearing. And just here we will stop this situation. We will simulate the situation of over lubrication. So we are at our next bearing. Again, we need to apply grease signed as blue with a blue grease gun. Alarm is not assigned, so we will press enter, take the measurement. Our initial measurement will be the starting point. We'll save it. Again, we haven't assigned any alarms. So in this case, we will add the message that lubrication is needed. This is a manual message, and I will choose this time free mode. So as you can see, this represents my initial measurement, and now I will add certain amount of grease here, and I will press enter to see what happened. Okay, so you can see that was a bad decision. It's over lubrication. I will just now inform LUBExpert about number of shots I added. I added 3 shots, and I will call it a day and say, okay, finished, process is saved with over lubrication. It was a clear decision because it was seen on the screen, and I will press enter to acknowledge this message, and I'm done with my task. So what we need to do next is to go back to our UAS3. Now we are back in the office, and we will download the data from LUBExpert to PC and transfer. Since I was working with LUBExpert Dynamic, you will see that I have a lot of data here. So first of all, this is the first bearing we did. What you can see on the screen here that I have two dynamic measurements. So this is a pure condition monitoring data. And you can see this one is the measurement before lubrication. This one is measurement after lubrication. You have a time waveform, you have spectrum, your complete condition monitoring data is here. And also we have what happened in the field. So we started at approximately 62 dB microvolts. That was our initial measurement. Few seconds later, I added a message that lubrication was needed. It's marked with M. That means it's a manual message. So that was my decision. And the end of the process is quite low, somewhere around 48 dB microvolts. So it's obviously a very successful process. And this is the quantity of grease I added. The static point has been automatically generated. So here in static point, I have a lot of additional data. So you can see the process itself. So let me just close this a little bit. First of all, what you see is that lube alarm is green and the process ended with lubrication success. As there is no mark F here, That means that it was done in a guided mode. So RMS was initial 61.8, the final RMS was 47.8, so it's very successful process. Here you also have max RMS, you have peak, crest factor, which are not so much relevant for us at this point. So let's remember what we learned before. I will click on selection, parameters. I will remove peak, crest factor and date. No, I will leave date, that's a good idea. Sensor serial number, this is the data we also have. I don't need it maybe at this moment. Instrument serial number, operator, good idea. Lube alarm level, grease name can be here. So all the other stuff can be here. Software ID, not necessary to have it here. Sensor name, we always know that we can see it also here, so I can remove it and I can click save. So you can see now that situation is on the screen is much clearer. Now I selected exactly the data I want to see. I missed something, obviously, so let's go back. I will remove max RMS, I will leave peak, and I don't need to see manual input as well. So you can see now that I have RMS, peak, lube alarm is a green oil dot, which means lubrication success. It was done in a guided mode. The grease name is blue. Number of grease shots, we entered 24. Total grease quantity is 30 grams. It happened on this date, this time. The acquisition time was 5 seconds, and the operator was default because I haven't defined any specific operator, which we will do in a next step. In this screen, in this graph, you can see your static trend. So your RMS is here shown, and you can see actually what happened at what time. Initial measurement, final measurement, grease quantity, and event. Event was the message I added. That was my decision to lubricate, so I added lubrication needed. Let's go to second bearing that we greased. So we have the same situation here. Again, all the data. Initial RMS 40.3, final 46.1, obviously over lubrication. The lube alarm is orange, over lubrication, and there is a small letter F, that means it was done in a free mode. The same grease name, number of grease shots, all my data is here. So you can read all your data here perfectly. And another thing you can see here is your initial and base readings extracted from this graph out. In later stages we will make some more measurements, and you will see why that is so important. So you will have one line showing you all your initial measurements and one line showing you all your final measurements. So you can nicely and visually see what happens, what was the condition every time of the bearing when you visited it, and what was the condition when you left it. From there you can quite well read your possible interval corrections and overall condition. Here you have your process statistics. In this case we have only one process, and that one process was over lubrication, so it's 100% over lubrication. And same as in previous bearing, we have condition monitoring data. We collected dynamic data during our process, so that data is here. In next step, we will add some alarms, and then we will do another process, so you can see what happens when you have alarms, and then you will have automatic messages and automatic instructions. Let's continue where we stopped last time. So we went through one process of replenishment on these two bearings. Now we have quite interesting data here. So we successfully lubricated it. Again, setting alarms properly is the matter of training for LUBExpert users. Here I will just show you how to do it, and in this case we can say that based on more data, not just one, that let's say we can put our initial alarm at 52 or 53 dB microvolts. So you remember that you can enter a new alarm here, or you can set the node alarm directly here. So let's for the moment introduce new alarm. So we'll call it new. It will monitor my LubeSense. Alarm name will be pump non-drive end, and it will monitor RMS. And as I said, I will put values 53, let's say 59, and as a danger 65, and I will press save. So now I have this alarm in my, as we call it before, alarm bank or alarm database. So now I can right click on this point, set alarm from template, and the only alarm offered is the alarm with LubeSense 1. If I click here, nothing will happen because I have only one. If I have more of them assigned to LubeSense, I will be able to list them and choose one. So I will just attach it here. So you can see it's applied immediately. Now when we go back to our data, we see that last time we lubricated, based on this freshly assigned alarm, the initial condition was warning, and when we finished it was normal. In our next bearing, we don't have enough data to assign alarm, because we cannot know at this point if that was already heavily over lubricated or it was in a perfect condition. We will need a little bit more data to be able to set up the alarm properly. So now when we transfer the data to LUBExpert, this alarm as well will be transferred there. So let's do it again. We will upload to LUBExpert. Now again, our tasks and tree structure, all the alarms, everything will be uploaded there. So this time we'll do it a little bit differently, so we can show you more options in UAS3. Okay, and now we can go to the field. Okay, so we will be using our Rhapsody box again. So this time let's use another scenario, lubrication sex 2. So in our LUBExpert we will select work orders, grease task, pump number 2, pump non-drive end bearing. Okay, so we need to use a blue grease with a blue grease gun, and now we see that alarm is set at 53 dB microvolt. Press enter to continue. Okay, here is our initial measurement. If I change amplification, you see I will be warned that amplification is too high, and I will take initial measurement. And I'll click save. So now you can see the alarm has triggered, and I am informed that lubrication is needed. So I will choose this time free mode, and I see the alarm level. I see that my condition is alarm at this point, and I will enter certain quantity of grease and press enter. So I'm doing it now upside down, because normally my first grease replenishment should be in free mode, so I can learn more about bearing. But right now we are focused on UAS3 features. So you can see here that it went down. I will enter the quantity I injected, which is 3, 4, 5, 6 shots, and I can continue again because it's going in a good direction. And I will again press enter and let LUBExpert do the job. Remember, I'm in the free mode, so decision about how much grease to put and when is mine. So I will just say to my LUBExpert that I put this time 4 shots. It's slightly going down still, so let's continue. Okay, it's not changing much, just a little bit. So I again injected 3 shots. So let's see once again what will happen. And in free mode, I'm making my own decisions. Okay, not much has changed. I will enter 3 shots that I injected, and I will call it a day and stop it here. So process is saved with lubrication success outcome. I started at 62, the end was 46.1, so I can say that I'm quite happy about it. So let's go back to our UAS3 and download that data that we just did in the field to UAS3 and see how does it look like. Okay, done. So let's see the bearing that we greased twice. So first, what you can see, this is our first process. It was in a guided mode. As you can see, there is no F here, and we have initial and final measurement. We have status and all the data that we set in our parameters to be displayed. Then, a little bit later, we did the process again. We started with warning, but now, as you can see, we are doing it in a free mode. So this is my initial reading, and then I have step 1, step 2, step 3, and final step 4. So from UAS3 you can read how many steps were done, but not only that, you can see how much grease was added at each step. So in step 1 I added 6 shots of grease. Then I added another 4, which is now 10. Then I added another 3, cumulatively 13. And then in final shot, obviously I added 3 more because my final quantity is 16 shots or 20 grams. So here you can see absolutely all the details about what happened and what was the development of the indicators. So we started at 62.1. Next was 47.8, 46.9, 46.4, 46.1. So here you can see, when you are working in the free mode, absolutely all details about entire process. Now let's go back again to initial align and baseline. So here you can see that the first grease replenishment started here, ended here. My next one started here, ended here. In future, this graph will probably look different and it will be more complex because it's not likely that you will find a bearing in identical condition every time you visit it. And also it will not be in identical condition every time you finished your lubrication process. So from here you can see the development each time when you visit the bearing. Here, I will just remove max RMS, peak and crest factor to make it more simple. Here now we have all our data. Here is our first process. So we have a beginning and end. And there was a manual message lubrication needed because it was my decision. And this is the grease quantity. But this is my second process. So you can see, you can read it very nicely. You can read it very nicely in UAS3. We'll just go back and okay. Now I see grease quantity and RMS. So in my second process, you can see here was my initial measurement, and there is a message automatically added: lubrication needed. So the first time we didn't have that because we didn't have any alarm. Now we have alarm assigned, so LUBExpert automatically decided a lubrication is needed, and you can see that fact in UAS3. So if you are using UAS3 and somebody else is actually going to the field, you can perfectly well see what was going on in the field. So this is the initial measurement at exactly this time at 1 o'clock 50 seconds and 50 minutes and something. You can go down very, very, very precisely. So this is the moment when the first measurement was saved, and the message that operator saw on the screen was lubrication needed. The next one was done a minute later, which is okay. 1 minute later for 6 shots of grease, that's fair and nice, not too fast. And then you can see the next step and next step and next step and next step. So each of the steps is here. You can clearly see it with timestamp, so you can go as far to warn your operator if he's adding grease too fast. Sometimes people tend to do that, and that's not a very good idea. So you can read that data also here and maybe instruct him to do it a little bit differently. So as you can see, all the information about the greasing process is in your UAS3, because by using UAS3 you are using a strategic center for your lubrication activity. So you should be able, and you should always do it, read your data and make your conclusions based on that data. All data is here, everything is offered, you just have to use it, and this is the way to use it. If you click here and you click on events, you go up one step, non-dry vent bearing, events. Now you can see all the events and messages that happened. So you can see that the first time we had lubrication needed manual message, then we had lubrication needed automatic message. So even in case that LUBExpert operator in the field ignored the message and added manually something differently, for instance, if there is an automatic message lubrication needed, but he decided not to grease, he will need to enter message lubrication not needed. That one will be marked as M, manual, so you will see the difference and understand what actually happened in the field, what was the recommendation, and what was the action done by operator. So all the data is perfectly well displayed. Go through it, because it's critical to make your decisions based on data. So I hope this helped. We'll just mention one more thing. Now when you go to reports, lube, you can see overall lube consumption. I want to see it for the tree structure, your manual. And I want to see report. So what is my grease consumption? Just give it a second to process. Okay, so this is my report about grease consumption. In this tutorial, we also only used one grease, but if you have used more grease, they will be shown here. So you will see that the overall consumption of the grease. But you can also do it in a different way. You can make lube consumption comparison. So I have 2 bearings here, and I want to see the consumption on these two bearings. So you can see it here. This is my drive end, this is my non-drive end. Of course the quantity is different because we greased this one twice, this one only once. Now there is always a good question why it's a different quantity here, and again please refer to our training and you will learn more about it. It's a very powerful tool. So if you have several similar machines that you expect to behave similarly, and then you see excessive grease consumption on one of them, then you can ask yourself a question, what might be the problem? Because as opposed to time-based lubrication, here quantity is a good indicator. In time-based lubrication, you are always adding the same quantity. In a condition-based lubrication, you are adding the quantity that it's actually needed. So it's a good indicator to ask yourself why this bearing needs so much grease compared to another one. And this is why this feature is not only simple reporting to send somebody to say how much grease we use, but also you can use it to understand more about your assets. So I hope this manual helped you, and see you in following chapters.